Hello everyone, welcome back to Quantum.
Imagine a world where a single particle can pass through two separate doors at the same time, or where simply observing an event can change its outcome. How did scientists uncover these mind-bending phenomena, and what does it reveal about the true nature of reality? Join me as we delve into the fascinating history of quantum mechanics and explore the discoveries that revolutionized our understanding of the universe. So what is quantum mechanics? In easy words, quantum mechanics is one of the branch of physics that describes the behavior of very small particles like atoms and subatomic particles. It explains that how these particles interact with energy and with each other in a way that is very different than our everyday experiences. Now we know what is quantum mechanics, let's dive in its history. In the early 20th century, physicists were grappling with a perplexing problem: the behavior of light and matter at atomic scales defied classical physics. This journey into the unknown began with Max Planck's groundbreaking insight in 1900. Planck proposed that energy, emitted or absorbed by matter, does not flow in a continuous stream as classical physics suggested, but rather in discrete packets he called quanta. This revolutionary idea laid the groundwork for what would become quantum mechanics. Just 5 years later, Albert Einstein expanded on Planck's theory with his explanation of the photoelectric effect. Einstein proposed that light itself consists of these discrete quanta, which we now call photons. This revelation not only earned Einstein the Nobel Prize in Physics, but also set the stage for the dual-wave particle nature of light and matter. In 1924, Louis de Broglie furthered this notion by proposing that if light could behave as both waves and particles, then so too could electrons and other matter particles. His hypothesis of matter waves was confirmed through experiments showing the diffraction of electrons. The 1920s saw a flurry of groundbreaking developments. Werner Heisenberg's uncertainty principle, formulated in 1927, shattered the classical belief that one could simultaneously know the exact position and momentum of a particle. Meanwhile, Erwin Schrödinger, also in 1926, introduced his wave equation, which described how these matter waves evolve over time, thus laying the foundation for wave mechanics. The Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg in the late 1920s and 1930s, provided a philosophical framework for quantum mechanics. It argued that particles exist in multiple states until observed, and that the act of measurement itself affects the outcome. Paul Dirac's work in 1928 brought quantum mechanics into the realm of relativistic physics with his formulation of the Dirac equation. This equation described the behavior of electrons moving at speeds close to the speed of light and predicted the existence of antimatter. The 20th century continued to unravel more mysteries. The EPR paradox, formulated by Einstein, Podolsky, and Rosen in 1935, challenged the completeness of quantum mechanics, setting the stage for John Bell's theorem in 1964. Bell's theorem suggested that quantum mechanics cannot be fully explained by any theory based on classical concepts of locality and realism. By the mid-20th century, quantum field theory emerged, merging quantum mechanics with special relativity. Richard Feynman, Julian Schwinger, and Shinichiro Tominaga independently developed quantum electrodynamics (AQED), successfully describing the behavior of electromagnetic forces and demonstrating the most accurate predictions in physics history. Today, quantum mechanics underpins much of modern physics and technology. From the development of lasers and transistors to the promise of quantum computing and cryptography, its impact continues to shape our understanding of the universe. As we conclude this journey through the fascinating history of quantum mechanics, we've explored how visionary minds reshaped our understanding of the universe, from the mysterious behavior of light to the profound implications of quantum entanglement. But this is just the beginning. Join me on this quest for knowledge, subscribe to my channel, Quantum, and hit the bell icon to stay updated on future explorations into the frontiers of science and technology. Together, let's continue unraveling the mysteries of our quantum world.